Welcome to the intelligence team. We're absolutely thrilled to have you here. As a new junior developer joining us, it's totally crucial to understand how we actually build our scalable intelligence systems from the ground up. So today's explainer dives deep into advanced RAG. That's Retrieval Augmented Generation, of course. But more importantly, we're going to look at how it serves as the ultimate foundation for planning and executing really complex tasks. We are moving way past basic search here and transforming these systems into robust, connected reasoning engines. We have a pretty packed roadmap for this explainer. We'll start by going beyond basic search, then we'll cover graph-based chunking, explore multi-hop reasoning paths, compare the two approaches, look at a combined production system, and finally wrap up with how we build connected knowledge. So let's just jump right in. Starting with Section 1, Beyond Basic Search, moving from isolated chunks to intelligent synthesis. You know, when you're just starting out, it's super easy to think of RAG as just a simple, single-step workflow. It's kind of like a basic Google search, right? You make a one-shot request and it fetches a single chunk of data. But here's the reality. When you're dealing with complex tasks, those one-shot requests are inherently flawed. They literally consistently lead to missed context and, worst of all, hallucinations. To build a true research assistant, you have to engineer planners and multi-step workflows. We have to completely move away from flat data and build connected knowledge systems that actually understand relationships and orchestrate complete, synthesized answers. This is exactly how planners massively reduce errors compared to those basic one-shot requests. All right, let's move to Section 2, Graph-Based Chunking Explained, or as I like to think of it, building the map of knowledge. For any developer aiming to build scalable, intelligent systems, you'll quickly realize that you absolutely need hierarchical structures. You just can't rely on flat text files floating around in the void. Graph-based chunking creates this essential hierarchy by establishing explicit relationships, literally turning isolated data into a beautifully organized web. In this kind of structure, every single chunk becomes a node, and the deliberate connections between them form the edges of a really complex graph. To put this into perspective, think about that expense analysis system you're helping us build right now. In a graph-based system, each chunk stores its content, its metadata, and explicit links to other chunks. So if you have a node containing, say, freelancer tax rules, it doesn't just sit there all alone in isolation. It explicitly knows its neighborhood. It links directly to other related expense deductions within that hierarchy. It is actively aware of its surrounding financial context, which is just incredibly powerful. And this fundamentally transforms how we execute a step in that expense analysis process. Instead of just searching for your top keywords and stopping dead in your tracks, you actually expand via those graph connections. So if the system's goal is to compare freelancer versus salaried benefits, it pulls in the entire relevant financial neighborhood. It traverses the graph, capturing all the necessary context around the topic so you don't miss any of those really crucial edge cases. Which perfectly tees up Section 3. Multi-hop reasoning paths, traversing the map dynamically. Because honestly, sometimes a pre-built neighborhood just isn't enough to get the job done, and that's where multi-hop chunk linking comes into play. This is essentially task decomposition in action. To effectively decompose a really complex task, the planner takes a very specific sequence of actions. First up, it parses the complex query. Second, it identifies the first logical hop to make. Third, it retrieves that initial data. Fourth, it evaluates the context it just gathered. And fifth, it formulates the next query based on what it learned. It creates this highly dynamic, on-the-fly chain of reasoning. Let's actually trace this planning journey for our expense analysis example. Instead of relying on a flawed one-shot request to figure out why freelancers pay more tax in certain cases, the system orchestrates a proper step-by-step journey. Step 1, it hits the general freelancer rules. Then it hops to Step 2, gathering the deduction differences. Then it takes another hop to Step 3, grabbing the comparison logic. And finally, it synthesizes all of those steps together. The system is actively building a reasoning path as it goes. Let's transition to Section 4. Graph versus multi-hop, comparing the two architectures. Now, you might be wondering how these two approaches stack up. Let's directly contrast them. Graph-based chunking basically represents a single-step workflow that relies on a pre-built structure. Because it uses traversal retrieval, it's much faster, but it really only offers medium flexibility. On the flip side, multi-hop linking represents a true multi-step workflow. It creates a dynamic chain through iterative retrieval. So yeah, it's a slower approach, but it's highly flexible, allowing for on-the-fly dynamic planning and reasoning when you're dealing with totally unpredictable queries. Okay, Section 5, the combined production system, bringing it all together. This right here represents the core orchestration flow for a true production-grade assistant. It is a complete step-by-step journey where the planner retrieves the initial data, expands the context via the graph, reasons through the nodes using dynamic multi-hop logic, and finally assembles the complete context to send over to the LLM. I can't stress this enough. This multi-step orchestration heavily reduces errors compared to just firing off a single-step LLM query and hoping for the best. And finally, Section 6, Building Connected Knowledge, Design Considerations for Developers. So as you help us build out these hierarchical structures, I need you to keep these exact best practices in mind. First, link quality is literally everything. Good links equal powerful reasoning, while bad links just pump noise into your system. You also have to implement strict depth control. You want to cap the planner to an optimal 2 to 3 hops to keep the orchestration flow fast and efficient. You're also going to need a scoring strategy that ranks chunks by relevance, connectivity, and confidence. And lastly, latency. Graph traversal inherently adds overhead, so you absolutely must use caching to handle it. I really love this quote, "Flat chunks store data, connected chunks create knowledge." Honestly, that is the fundamental mindset shift required for this job. As you move from basic data retrieval to engineering an intelligent planner, you aren't just finding text anymore. You are actively architecting the foundational relationships that allow the system to truly reason. By mastering task decomposition, hierarchical structures, and multi-step workflows, you aren't just building a glorified search bar. You are building a robust reasoning engine. I really hope this deep dive helps you conceptualize your role on the team as we build these systems together. So, the question to ask yourself is, will your next system be a simple search tool or a connected reasoning engine?